Welcome back to more Oxygen Not Included for our Beginner's Guide. So, last episode we went over a volcano tamer. You can see our tamer's having a bit of issues, mostly from having to cold start. So what that ended up doing is we have added a lot more material into our boiler than we kind of want to, which has resulted in the auto sweeper grabbing too much for the conveyor loader before it can kind of adjust. So I have readjusted a lot of our temps to now work more for 180. It'll let material. We'll still let material out at 210. Actually, let's get. I'm just gonna get everything kind of set to the 180, and then let's get everything fixed in here. Nines. The other thing I did, because I think it was something that may have been causing issues, is these temperature sensors I did switch all over to copper. And it's a thing I've just mentioned with steel before. Steel has a lower conductivity than what copper, gold, I think cobalt, they're all kind of roughly the same. As well as having a higher... find the exact thing there. Yeah, steel has a lower thermal conductivity while also having higher specific heat capacity, so it takes far more energy for these sensors to update their values, which may be why we were having issues of too much getting thrown in. Besides that, there you may notice we have some pumps down here. Fortunately, we didn't start working this, or this cut in too deep. Carrying some material through apparently froze our liquid lock, so we did switch this over to petroleum. Not sure where all the chill came from for the stuff we were moving. I think it was a lot of sandstone, was probably from our frozen core. But we switched this over, threw down some pumps, took a while to clear everything out, got this all vacuumed out, and then we also vacuumed out over on this side. We have moved our Drecos. They are up here now. Nothing's really changed on the design. We are just doing regular Drecos now because all of our plastic, we will just be able to make plastic press. And we have like over 100 tons of plastic. We have more plastic we're probably going to need. The only thing different, we did add this tempedizer and water with a thermo sensor to kind of just run a loop, make sure this all gets up to temp. The idea is we'll probably have 4 up here, is kind of how I designed this, but I got to get this out of the way. For now, we went with 3 to get more renewable reed fiber, because reed fiber can be a bit of a bottleneck for some stuff. Besides that there, I have kind of cleared out the area for our petroleum boiler. Still have a few things to set up, but it took a while to get this dug out and move all of our material, as well as we just got to wait for this volcano to kind of fill up. The volcano itself may not be able to power this, but we have all this debris from the core that we'll be able to use for it. And let's speed things up. Let's get this fixed real fast. I guess this one I don't have to just disable auto repair. We'll just deal with the fact there's damage in it. Just the thing, it's the thing we noticed with the iron volcanoes, of where we put it up top, it's too hot up there. Get this going again, and it should get our temps up again. It's up to a 9. Besides that there, our colonization rocket is back. We did clean everything off the water planet. We're in the process of getting it cleared out, but due to kind of how I had to set the auto loaders. Go, and then 6s now. Just block this off again. Did make sure to put all insulated tile here, so none of this petroleum or other things touch this hot abyssalite. This is the danger of building down in the core. But we'll keep an eye on this here. And if things aren't working well, I will add a disclaimer and any corrections to the previous one. Besides that there, I think the only other thing, we are almost done over on Dolan. This aqua tuner did eventually break itself because this never melted. And the reason it's never melted is I placed the temp chip place on the wrong tile. I should have placed it up here where the vacuum is, because it was just slowly exchanging. They were just poorly exchanging heat to the insulated tile around the cold environment, meaning it would never melt. Anyway. Keep an eye on that on our system here. Just trying to get the temp right where we just have too much material in here that we risk kind of overfilling. Anyway. So for a petroleum boiler, what we're going to do is we're going to use the same kind of dropper and our debris, and we're going to use that as our heat source. You've probably seen the age-old design of just do the dropper next to a spike and you dig it out, or spike onto the core. And the problem I have with those is, one, it's really easy to overshoot your temp with them, even trying to adjust. They can be really finicky on trying to adjust your temp to not overshoot. And then the thing with the design you've probably seen a lot, and it annoys me so much with petroleum boilers, why I like this design, why I finally came around to them, and also part of the reason I still don't think they're needed for a lot of stuff, is if you go to the wiki and you look up how to build a petro boiler, and you look at the design, the disclaimer on it is, this build is considered outdated by the community and has several flaws that will cause its failure in several possible ways. Use it at your own risk. And there's no update to it. My design is probably not going to be an update to it either. It's not really my design. I got this from Shana Plays in one of the Chaos Crew play-alongs, and just adjusted a few things. I kind of like how it just lines up under a volcano, or you can get it to. So we dug out our area, and then the main thing with it, and I'll link the article on the forum, to doing your counterflow heat exchange is, there's different ways to do it. We could have done stairs, various other things. I've had consistent luck with going roughly 10 wide and then getting about 6 to 7 kind of rows of pipe. So roughly 70-ish insulate or radiant pipes. We have access to aluminum. We can build this all out of aluminum. We're going to build it out of gold, copper, cobalt, kind of that tier of material, because that is something you will have access to. But we conveniently had enough height here, kind of buck up against the neutronium a bit, and then I did just kind of, in the event the magma kind of melts, I don't want to contact. It shouldn't happen over here, but over here, because there is some magma, I just threw down some regular obsidian and blocked it off. So the main reason it comes down to is, why would you build a petro boiler, and what are the main reasons to do it over just using the oil refiner? Because we use the oil refiner fine. We've done lots of stuff with it. It's working perfectly adequately. But the thing I mentioned when doing oil is, for the oil well, we put a K of water into... We put 1 kilogram per second of water into it. We get a third of a pipe of crude oil. So we need 3 of them to fill a pipe. And a pipe is 10 kilograms a second. So with the oil refinery, we can put 10 kilograms a second of crude oil in, and we'll get 5 kilograms a second of petroleum out. And then each petroleum generator can burn up to 2 kilograms a second of crude oil. It will then output 750 grams of polluted water. It'll make 2 kilowatts of power and outputs 500 grams a second of CO2. So doing that there, we have an input. Realistically, I'm going to assume you only have 3 oil wells. On a lot of how stuff spawns normally sets stuff up, you're probably only going to have 3. You're probably only going to have 1 full pipe to work with. So if we did that there, we're inputting 3 kilograms of water, and our output is we would get 5 kilowatts of power and 1.8 kilograms of polluted water. So we rough out our math on that there, and we include the power for having to use the oil refinery. A lot more power involved on the exact math, but we're not going to include the oil well and pumps and other stuff because both builds are going to need that. Anyway, we're effectively spending 1.125 grams per second of water to turn that into 4,000 or 4.52 kilowatts of power, which is pretty good if we were to run them nonstop. If we did this as a boiler, though, so the oil well's the same, but if we heat up crude oil, if we get it up to 400 degrees, it 1-to-1 turns to petroleum. So we turn 10 kilograms of crude oil into 10 kilograms of petrol. We then have 2 options for how we would burn that. So we can burn up to 5 petroleum generators. So there's 2 ways to do it. We can have 4 petroleum generators, and then we would get the same amount of water back once we run it through a water sieve, or we could boil it too. We're just going to run it through a water sieve. So we would be we would be neutral on water, and we would be making an excess of 2 kilograms per second of petrol and 8,000 watts of power. Alternatively, we could burn all 5 generators, and then instead of making excess petrol, we're making 750 grams of excess water per second, and we're making 10,000 watts of power. So for now, and what I did most of the math on, and I may change it to some other stuff, is we don't really have to figure out anything to do with the CO2. We could just fit in here. It'll go forever. But for the CO2, the main thing you do with it, you feed it to slicksters. So a petroleum generator makes 300 kilograms a cycle of CO2. So each can feed 15 slicksters. Because I wanted the option to run 4 or 5, depending if I needed petrol for other things or water for other things. It's also just easier to get rid of the water. There's a lot less of it. I mathed my slicksters out on I wanted to be able to sustain 60 slicksters. Because 4 times 15 is 60. So we did 1, 2, 3, 4, 5, 6, 7 ranches. It's 56 slicksters. And that's just because I wanted some leeway. And because I ran out of geyser. Having excess CO2 doesn't really matter. These won't overpressure. We got to reroute this natural gas anyway. That's kind of the stuff we plan for. Because the thing with the petroleum boiler is, unlike most of our other power sources and projects and whatnot, we never want this thing to stop once it starts running. That means we need a plan for what we are doing with that 2 kilograms a second of petrol, or that 750 grams a second of water, and all that CO2. Because once we start this, at minimum, 4 of these will run forever. That's kind of why I put these switches in here. So I have the one that kind of just overrides the smart battery to turn them all on, and then I have this switch to determine do we want to run 4 or 5 petroleum generators. Because even if I just decided I'm just going to throw it all into a big tank, if that tank fills, then something will start backing up somewhere. So either the water will start backing up and flood in here, or if it's the petroleum starts backing up here. And if it backs up far enough, we touch our heat spike and bad things happen. So we'll probably... Originally, I planned on doing 4 and just making infinite storage for the petrol. I think we'll just plan for 5, and I'm just going to throw the excess water into an electrolyzer and burn it for power. Or just vent it to space. When in doubt, vent it to space. Anyway. Get a look here. Temps look... Everything here looks a little more stable now that we kind of dropped down to the 180, but we'll keep an eye on stuff in there. Anyway. So we dug our area. We have all our line run. Now we need to kind of figure out our droppers and our logic. So, the first thing we want to do... Find my reference. Okay. I did open up here now, so let's get the rest of our walls in. As well as speed things up. So we don't want this side open, we want to close this off. Also want to get a bottle emptier. And everything here is made of obsidian. All these ladders are obsidian. All of our metal is gold. The excess piping here is I'm going to try something different to see if it works for kind of cooling some stuff in here. If we have to, we will loop it onto this turbine, and we may just want a separate loop. My understanding of how the logic works, we shouldn't need to, but it's more a limit of our input that might cause the issues. I'm going to wait on filling this just because I got to carry materials through and I don't want it to flash on me. Anyway. So, let me figure out for my automation first. So, I want an AND gate here. 2 separate AND gates I want. There's a couple... Just trying to think for my logic at the moment. Steel tile here and here, I know that much. Or I remember that much, I should say. Because I am going to add switches in so I can make sure that no material gets added in, as well as I can disconnect our heat spike from our waiting chamber. It'll take a while for this fill. I don't know how well a minor volcano will work for this. I've only done this here with a major volcano. Keep that in mind. I will keep an eye on it as kind of the playthrough goes and update the description if it's an issue. There we go. I think we were just floating a little too close to the sun before there. Should be able to... That is an unreachable build. Let's just take this insulated tile out for a second. I'll just figure out my planning for stuff. So I had to kind of mirror my build, so I'm trying to just wrap my head around replacing some of the logic. Just want to avoid anything getting too hot while we prime it. There we go. This will stay closed even though... what am I doing wrong? Okay, that I definitely don't need there. I know that much. Cancel the deconstruct on that. It is... because I need 2 AND gates. There we go. And the other AND gate. Because our logic is supposed to be like this. Because I want this switch to always be able to keep this closed. Yes, I could just use a snipping tool. I like just having switches. I don't know if I need the timer sensor here, but we're just going to use the timer sensor again for the dropper. Everything down here now. Can put the tile in. Ladder out of the way. Now we want to get some diamond tiles down. This is going to be kind of our contact point to our debris drops. So the same kind of thing, it'll drop down here and then teleport into this tile. We also want a diamond temp shift plate. Also want a thermosensor. I may regret this again. We're going to build this out of steel. Just because the amount of heat that's going to be on this side will be maybe higher. Or no. Build it out of gold. Don't make the same mistake again. You need the stuff out of there. not have a bottle filler for water? Oh, they're just loading it that way. Set this to petroleum and enable auto bottle. And then we need to grab some regular water here. Because where we have the temp sensor in that tile, we can't have that stay a vacuum. We need to put something in there so it can... I guess the other option is we could do lead. Wait, 1, 2, 8, 2, 11. Or 0.184. I'm going to use steam just because it's what I used before. Lead be an option. It's the problem of getting the lead to melt and then also getting it to be the correct temp. Always just the lag in sensors are always just kind of what we want to watch out for. Ah, sweep only. I just need them to make a bottle, and then I'm going to tell them to move it. Kind of just the easy way to do it. Now relocate. Then we want to keep an eye on this filling with petrol. You may notice I have this petrol pit now. I kind of forgot about filling this and had to get a bunch of petroleum cleared out of here. It was before I dug down here, thankfully. Get this down just so we can make an atmosphere. This is another one of those things, I mean, to be fair, if you have access to the other stuff to make this, you probably have lead. There we go. Now... it's going to go over like this. Then we'll close it off. There we go. That should avoid adding more material in until we get it stabilized. Alright, and then before I close it off, we got to do our shipping lines. So the way we're going to do this is we're going to run debris through the diamond to get the heat out of the debris, and we're going to use that to boil our petrol. So we will need the loader and the sweeper. We do want to build these out of steel. And we're also going to want to build our rails out of steel. Oh, I just have to remember how to make a loop. This bridge is this way. Just trying to remember where the rest of this is going to go. Loop around our diamond. Conveyor bridge, and then we have a shut-off. What am I doing wrong? Oh. Then a bridge again. This way it keeps circulating material until it's below the temp. And then we could also run it down to here to put more heat into the system. For now, gonna loop it out. You will need the rail thermosensor for this. So this is the... Like I said, we're going to be using this material here. So my only concern is the loader overheating. But, like, loader heat exchange is weird. So where it's in the vacuum, as long as the rail itself is not running through this area, it shouldn't affect our cooling. It's a matter of, is it going to exchange heat with the conveyor loader or not? But I can adjust some logic to prevent that, where we're going to be... It's kind of the problem we had with the other one. We're going to be using more material than is probably intended for this, while we kind of get it primed. But this will help with priming it. Get rid of some of these additional ladders now. And then I just have to get power to it, where I just got to find somewhere to throw a transformer. Okay, I'll wait to get things swept until we go out. Then the other thing we need for our logic is just going to be getting our boiling chamber, which is going to be here. So we go with our plumbing. Plumbing's going to go to here. Get it. Just try to avoid the oil, like, spilling over. We're going to add one more tile up here for after. Shouldn't have to service. We'll... Shouldn't have to get over this side. Might be a little awkward getting to this side. I didn't leave enough room. Ideally, we don't have to get back in here. And to help with our temps a little, we're just going to add more diamond tile. I don't want to put the diamond tile here because then it'll exchange with this insulated, and I want to make sure as soon as petroleum leaves our boiling chamber, it no longer has access to any of the heat. We do those, and then we can get these building, and then we want some automation, which is going to be... I want a liquid element sensor here. And I also want a thermo sensor here. So the thermo sensor is going to be going to where our connecting door is, which I do need to run power for. And then our element sensor gonna wait to run it for a second because I need to put a bit of oil in just to kind of prime the system. I don't want to fuss with or there's an easy way for me to do it. Going to use a knock 8 just because this makes it easier for kind of priming the system. Then we also want to get another steel door here. So this way we can disconnect our chamber if it's getting too hot. Okay, so take a look. Make a save. Or we take a look over things. Let's save. Alright, so our timer is going to be on 1 and 10. This timer's probably... Okay, I did set that back to 1 and 10. You want to go like 5 if you have to cold start. Okay. This send the marriage is going to be open for now until I fill it a bit. So for our debris sensor, we don't want to add more material unless we are, or send green signal if we are below 500 degrees. This one here, because we want to use the opposite. We send a green signal if we're below 406. We may fuss with that number a little more. And we can just use an OR gate here, because as long as we turn the switch on, it'll force the door open. If the door's open, then it's not connected. Over here, send green signal if below 500. Oh, right, send green signal if below 420. That's the plan. It's a good thing we caught that then. Realized my AND gate was built out of the wrong material. It's a good thing this wasn't going yet. Okay, let's disconnect there. So also glad I have this hard to get disconnected at the moment. Okay. Gold out of here. We're gonna have a little more magma here than intended, just because some stuff turned to debris while it was filling. Mostly only an issue the first time we start it. Six more %. We did have to drop down to only one rad bolt generator, just due to the amount of power we're generating here. Okay. That's fine. I can grab for now. Okay. Sweep everything out of here now. Green signal if above 100K. Same thing, we're working with very hot stuff, so we're gonna vacuum. Oop. Gotta sweep the stuff there. There will be a bit of cold obsidian in this pile, but that's fine. This has just all the obsidian, abyssalite, igneous rock I got from digging out here. Because we're going to need something similar to this anyway, to just take advantage of the heat that's still in the rock. Like 1,000 degrees or less. Just once it becomes a rock, it's not as good at transferring heat. Okay. We go to here now, so let's build our diamond. Now, close this up. Suppose while I'm waiting, I can get our crude oil in here. So we kind of just want to get like a good amount in these lower tiles, just so when we start adding the heat, it's not that there's enough mass there that it's not going to instantly become sour gas, but not too low that it like spills over. There, that way, if our heat ever falls behind and we get too much crude oil in our tank, then it will stop adding crude oil. Which is mostly only an issue when we're first trying to start it. But 200 should be good. We'll check now. Right, send green signal if above 406. And green signal if... Okay. Well, I should get power down here. Run it off of this for now. Very much need to clean up the power grid. A lot of mixed stuff. Oh, there's too much liquid here. Move it up a tile. Waiting for all this to get powered now. Make sure it doesn't fry itself when trying to go. Bigger concern. There we go. Okay, everything has power now. So let's get our heat first. I want to get... So if I turn this green... Okay, that's a mistake there. That's an easy fix, though. Oh, I forgot the one tile here, because it prioritizes going to the right. I do want to set this to igneous rock real fast, then. You can see this got up to steam. And we're just waiting for this tile to get built. You can see right now we're just trying to get up to temp. It's all up to temp then. It'll take a bit to go. Like, the reason I like this here is you're less likely to overshoot your temp, because the issue you run into is if petroleum gets over 540 degrees, it becomes sour gas. So in theory with this, we should be able to mostly avoid that. Because none of the rock will exchange with the loader. It just circulates here until it's below the 500 degrees. Similarly with the 406, just make sure we have enough temp there. Okay, there we go. It is kind of the annoying thing where I have it set up this way, is I need a lot of crude oil into the system before it kind of trips it. But it does help with that there, because I find it can kind of stagger a bit. But yeah, we have a lot of just igneous rock we can take the heat out of here. You can see, like, it drops very, very quickly once it is in. But this looping works similar to kind of just the overflow is. Yeah, it loses like 500 degrees on one trip. Okay. Sure this doesn't overflow. So we get more... Just waiting for this system to kind of prime, because as soon as we get more petroleum, the more the heat will counterflow. The entire point you do this. I do want to see, to help with this. Okay. I don't have a lot of great stuff, but let's make sure we're insulating everything. Because ideally our crude oil is getting to us at 95 degrees or close to it. So right now we're losing a lot of heat and transportation. And I did add the carbon skimmer here to kind of help hopefully keep it from overflowing too much. We do need more for the purpose of if we wanted to like truly keep up with it, but our petroleum's not running non-stop here. But we'll get everything running into insulated. That should help it come to more to ideal temp. Because we're starting at 80 degrees, so ideally we have it all run at 80. But there we go. We got everything running down now. Ooh, we got sour gas because that flipped over. Okay, let's load. Gonna load back on the cycle. I know what happened in just it had too much crude oil. So whenever it bubbled over when we weren't looking at it, just because of all the quick state changes, did force our petrol over, which then caused petroleum to touch our heatsink and flip elements. So because it's going to take an eternity to get that sour gas out, we'll just add a wall. There's not that much we have to get over to on the heat spike side anyway. So I can just put a wall, and that way the petroleum can never get there unless the pressure breaks. Double check. We are still vacuum. We are. Oh, we do not want that to be granite. To be obsidian. Please build this quickly. Obsidian. Okay. So we're just going to disconnect from the spike to make sure that doesn't happen while we're doing it. It's because whenever we're kind of first filling this and where it's a lot of material, it just can kind of flip over. And it's because I had a slightly different design before, and I had kind of the upper that's all covered, so it could have been an issue. We'll do this here. Would have been the smarter thing to do. Let's... There we go. We'll get our bionics flipping that over. Okay, there we go. Make a save. We're doing any hot stuff. Save often. Yeah, the oil coming in should be able to keep these cool. Go. Probably got to do the big bubble over one more time. But we mostly just have to watch that crude oil doesn't flip over to this side. The alternative, we could flip these here, but then I have concerns of the temperature not being accurate. I'd rather have the temp closer to the heat source. It'll take a while to run through all this hot material here. Didn't expect to do that. I thought I'd go over. Did stop itself. Okay, that got stuck there. Making sure the oil doesn't flip out. There we go. But we can see our incoming crude oil is much hotter now. Because we're coming in at 80 degrees, and then by the time we're getting up here, we're around 320. See if I can get away with running that now. It's like I see the temp going up, but it's because the crude oil temp is going up. So we've already gotten our igneous rock moved. Eventually this will drop down and get itself. Already moved a lot of rock. It looks like we're getting about 360. Like, the ideal, you get it as close to 400 as possible, but you're going to be limited by your material, how hot the crude's coming in at, but, like, our crude's coming in at 80 to 85, and we're getting it up to about 360. We could probably switch it to aluminum. Just the catch with aluminum. I guess I should use gold as an example. So gold, our capacity is 0.129 and thermal of 60. If we compare it to aluminum, we get a capacity of 0.91 with a thermal conductivity of 205. So it's, like, on paper, it's almost 4 times as conductive, but it's also like 8 to 9 times. It takes 8 to 9 times as much energy. So what it usually leads, like, aluminum will probably get it closer, but if we start having issues, then our temps get a little more swingy and stuff. But it'd be more the thing we'll have to see once we're kind of through all this debris, if this volcano is able to keep up with it or not. Then we may want to switch to aluminum. It may be a thing of looking in after to do... There's, like, actual math you can do to figure out, like, how much heat the volcano generates, which would determine how much crude oil we could run through at one time. And like if it's under what the there we go. So there's our first thing of crude. Like right now it's keeping up with us just because I have a lot of material to run through it. We'll have to see with the volcano after a while. Guess add obsidian and abyssite. The other material I have here. There we go. We got it all going up, and then I gotta use it for something. So we'll just run them now. Because we never want this to stop running. So the petroleum backs up, worst case scenario, it hits the heat spike, and then it's full of sour gas. If we're doing the excess water, then we run the issue of our water backing up and then causing issues. So it is the thing, like, we just have this run non-stop now. Trade-off, have 10 to 15,000 watts of power. For that reason, only want my tinker going to the petroleum. All our other power will still kick on if needed. But where our petroleum is always going to be running, then 370. Not the worst. But, like I said, it's easier to kind of demonstrate this using like gold or copper over aluminum, just because you may not have aluminum. And like copper is 0.3 and 60. Gold's a little better just because gold takes less energy. Then I think cobalt's also similar. Cobalt's more conductive, but also needs more energy. It's better than copper. Because if you start on like a swampy planet, you have cobalt. But like it's... yeah, we also want to insulate it because it's coming out at 100 degrees. But we'll set up things. Now what we'd want to do is basically just have this liquid pump run it directly back to the teleporter and then burn off the excess. So where we have this all running now, we can up our critter counts and start getting a bunch of slicksters. Similarly, this oil here, we're going to want to run that back in. So we have a little more oil than what we're actually putting in because of the slicksters we're going to feed. Like I said, we could work into getting the temps higher and then doing molten slicksters, and it's directly to petrol. It's kind of not worth it in my opinion. I don't know how well the abyssalate's going to work. We're trying to get the temp out. Well, we'll run through all this, and then we'll see where we're at. Like, we have all this material. We need to run through it. But, yeah, that's a dropper-based petrol boiler. So we have more power than we'll really know what to do with. Oh, why is... the oil slowing down a little bit? I know why the oil slowed down. It's because I also have this going into the base for the lube station, so that's kind of the logic I want to add with moving this oil over, is have this feed our bionics here, and then anything else run it to the boiler first, just so this doesn't overfill. So I did this all as mesh. They basically filled their own drowning chamber, but we'll have to add that in. That's all we really have to do. We will put a water sieve here, loop our water back just so it's feeding directly back into the oil reservoirs, and then we'll get our crude oil going into our various systems. Because I know it's gonna take like several cycles. Well, we'll be firing off the temporal tear next video. And then probably go and see how well this held up. But yeah, a couple things I didn't account for with having to cold start this. Okay, so below 180. Get this to actually work right. Whereas this is kind of set up now, I should be able to adjust the temps better. All back to above 200. Let's say 181, just so it runs. Go, drop in. But yeah, it always adds a little more than you think. So just kind of figuring out where the how much excess you need. I'll have to replay around with those sensors. They can probably get set back. It's just initially because we cold started it couldn't take material out of this quickly, so we had like 16 tons of material it could grab. So it was putting in more than it should have. But it's a risk of cold starting. My recommendation would be anytime you set a big like aqua tuner setup going, don't save and load until it's actually running to just avoid that problem entirely. Oh, we'll keep an eye on it. I fussed with some things about its size and stuff that may be messing with it. But it's always the cold start is always the scary thing with any kind of volcano setup. But everything looks to be holding pretty good there now. Everything here's doing pretty good. Didn't expect that to be a problem. Switch these all to steel then. I guess these are making a lot of heat. Gold amalgam has kind of garbage thermal properties. I want to get these at 9 so we don't fill up our boiler. Also make sure our cooling goes by our petroleum gens, because we don't want a bunch of stuff flashing. Oh yeah, I did move the rock crushers down so I could set up this stable. There we go. We'll make sure this here holds. The easy solution is we just fill everything with super coolant now. Probably the thing I should go over the next one is just getting our space material made and then why we needed that. Looks to have mostly held now. Because they weren't running full tilt before. But yeah, everything looks good. We'll adjust some stuff. But yeah, that's a petrol boiler. We'll make sure it holds for a couple hundred cycles and whatnot. But the last one I built lasted 2,000 cycles, more or less exactly like this. But anyway, that's our debris boiler. We'll see. This may not be able to keep up with a minor volcano. We may have to limit our actual input for that. But this would work for a major volcano. Just because of how we kind of limit our temp here, we shouldn't have any overshoot issues here, which are the main problem if you do direct spikes. Which your main fix, if you're doing this here more as a direct spike, then instead of diamond, you would maybe look to doing... Always got to get that side, and then you open the door. You'd maybe want to use gold or copper or something. Because the problem with diamond is just diamond transfers the heat so fast. So you want to be a little more safe with your magma room. Anyway, we'll keep an eye on things, see if anything we got to adjust here. Probably put some safeties so people don't pick up weird stuff. But we have all the power and petroleum we're going to need for the rest of this run. We'll get into space science and then finally fire this off, I think. Anyway, that's it for this episode. Thanks for watching.